Input is required to continue when the interaction icon appears in the lower left-hand corner of the screen. Motors can be found in cars, industrial robots, analog clocks, and a variety of other devices requiring motion. The two-wire 269 and 393 motors are physically different. The 393 motor provides 60% more torque. For this demonstration, the 269 and 393 motors will be treated the same and referred to simply as motors. You will have an opportunity to use motors with the PLTW activities. The motors are located on the rail of the test bed. Let's refer to these as right motor and left motor. Connect right motor to motorPort 2 and left motor to motorPort 3. Motor controllers should be used to connect the motors to the Cortex. Now let's launch the Robot C software and create a sample program to explore motor control on the test bed. Once the software is loaded, you will need to open the PLTW template file. Select Skip to bypass these instructions. Use the PLTW template file to create any new program. Enter general program information. Then save the file as your last name _motor. Open the Motors and Sensors Setup window. First, select Robot. Then select Motors and Sensors Setup. On the Motors tab, assign Port 2 the name Right Motor. Select the Type drop-down box. For this demonstration, select the VEX 269 motor. Set up port 3 with the name Left Motor. Again, select VEX 269 motor. Select OK to save the setup and close the window. Notice that the pragma statements at the top of the program have now been automatically updated to reflect your changes. Now that the motors are configured, let's test them before creating any code to make sure they work. To test the motor setup, select Robot. Then select Compile and Download Program. Verify that the Refresh drop-down box is set to Continuous. It's important to remember that motor speed values range from -127 to +127. Negative numbers reverse a motor's direction. In the Motors with PID debugger window, change the value in the power column next to the right motor to 63 and verify that the motor rotates. Then try changing the power value for the left motor to -127. Change the power value for the right motor to 0. Change the power value for the left motor back to 0. Then close the Program Debug window to return to the program in Robot C software. Now that the motor configuration is verified, let's set up the program that will tell the robot what to do and how to react to its environment. For the motor program, let's run the right motor at half speed for 5 seconds, and then run the right motor in reverse at half speed for 5 seconds. Let's identify this as the program's task description. Now let's create the program's pseudocode. We will consider complex behaviors first, then simple behaviors, and finally basic behaviors. The task description is already at the simple behavior level, so let's break the behavior down into basic statements. The behavior can be broken down with this pseudocode. Now let's write the program based on the pseudocode. Task main marks the beginning of the program. Your program must be contained between the curly braces. Let's begin by expanding the natural language library in the text functions window. In this instance, you'll need the movement library. You'll also need the weight library. Drag the first command, start motor, directly under the open curly braces. Define the statement's first parameter as right motor. Recall that motors have a speed range from negative 127 to positive 127. To run at half speed, define the statement's second parameter as 63. Insert a comment on the same line using 2 forward slashes in the statement start right motor at half speed. The next line of pseudocode indicates that the program will wait 5 seconds before executing the next behavior. The command wait is measured in seconds. Drag this command onto the next line of the program. Define the statement's parameter as 5. Remember to use 2 forward slashes before comments. Insert the comment wait 5 seconds. Drag the command stopMotor onto the next line of the program. Define the statement's parameter as right motor. Insert a comment describing this behavior. Drag the command wait onto the next line of the program. Define the statement's parameter as 2. Insert a comment that describes this behavior. Drag the command stopMotor onto the next line of the program. Define the statement's first parameter as right motor. Define the statement's second parameter as negative 63. Insert a comment on the same line to describe the statement. Drag the command wait onto the next line of the program. Define the statement's parameter as 5. Insert a comment that describes this behavior. Drag the command stopMotor onto the next line of the program. Define the statement's parameter as right motor. Insert a comment that describes this behavior. Drag the command wait onto the next line of the program. Define the statement's parameter as 2. Insert a comment that describes this behavior. Verify that the program aligns with the pseudocode. Now let's compile the finished program and check it for errors. Always double-check that you are using a full battery and that your Cortex is powered on. Select Robot, then compile and download program. Select Start to run the program. Any program errors or warnings will be displayed in the Errors window. A red or yellow X appears on the line number of any statement containing an error. The message will describe the error. A common error is a missing semicolon at the end of a statement. This concludes the PLTW instructional resource on motor and wait commands.